Hello, everyone, and welcome to Inflectra's Level 2 Test Automation series called Planet Test Automation First Steps. You're joining us for our first webinar in the series, and today's topic is automating web UI testing. Today's webinar will be presented by Denis Markintsev, a principal software developer at Inflectra Corporation. He is one of the creators of Rappi's test automation platform. He holds a master's degree in computer science and a PhD in mathematics, and has been working in the IT industry for the past 20 years in areas such as compilers, development environments, software verification, and testing. My name is Teresa, and I'll be your moderator today. Before I turn it over to Dennis, let's cover a few housekeeping issues. Today's webinar will last for about an hour and will consist of a theoretical part, a practical part, and end with a QA session. We ask that you save your questions until that time and use the built-in questions tab to send them in. These will then be read out and answered. Today's webinar will be recorded. In a couple of days, we'll make the webinar recording available on Inflectra's YouTube channel under the playlist called Planet Test Automation First Steps. Please note that this webinar playlist is unlisted for the duration of this series. So prior to February 1st, 2020, you will need a direct link to access the recordings. Links to each webinar recording will be emailed to you a few days after the live webinar. Or you can subscribe to Inflectra's YouTube channel to get notified when new recordings become available. At the end of this webinar, we'll also have a quick poll to get a better idea of the webinar content was relevant to the group's needs. Now, just to give you a little more information about the webinar series as a whole. Planet Test Automation First Steps is Inflectra's Level 2 Automation webinar series. This series builds on Inflectra's earlier test automation series, Test Automation Demystified. The Level 2 series moves beyond the fundamentals and dives into the major technologies where test automation is used. The 5 webinars will cover UI, desktop, mobile, and API test automation. You can learn more about the series by clicking on the URL shown in your handout and also on the screen here. For those of you not familiar with our test automation webinars, we recommend that you check out the Level 1 series Test Automation Demystified available on our YouTube channel. We are also pleased to offer Planet Test Automation First Steps as a certificate course. The series participants are eligible to receive a certificate of completion given that they meet the webinar attendance and quiz requirements. If you wish to get a certificate, you'll be asked to take a short quiz after each webinar. To make things easier for you, we'll send out a follow-up email that contains all the materials covered in the webinar, including links to each quiz. For a full set of the certificate requirements, please refer to the Frequently Asked Questions document linked in your handout. Last but not least, as I mentioned earlier, each webinar in the series has a practical part. We will demonstrate the key practical test automation concepts using Inflectra's own platform, Rappi's. If you haven't downloaded the tool yet, please visit www.inflectra.com/Rappi's. Feel free to use Inflectra's 30-day free trial. All right, with that out of the way, I'll turn it over to our presenter, Denis.
Thank you very much for the introduction, Teresa. It was very helpful. So let's talk about Web UI first. Let's learn more about the object we are going to explore. So from perspective of a manual tester and from perspective of a test automation tool, web applications look very different. A manual tester sees the UI that you can see on the left side of this picture, while a test automation tool sees a tree of elements. So I'll show what I mean. So by the way, for demonstration purposes in this webinar, I'll be using UI Test Automation Playground website. This is a website that we created especially for training purposes. So it is a collection of automation puzzles to solve. So it has a comprehensive list of such puzzles. So I'm going to open sample application. And this is how it looks from the perspective of a manual tester. So what manual tester does is recognizes images, finds edit fields, enters text, clicks buttons, and the application looks very different if we are talking about a test automation tool. So let me launch the web spy in rupees so we will see how a test automation tool looks at the application. So here it is. Here is our web spy. Let me track an element in the application. And here is what we see. The application, the automation tool sees the application as a tree. So this is a tree of elements, and each element has a well-defined structure. So for example, our username input field is a node in this tree, and this node has a tag, and this tag is input, and this node has some attributes: class, ID, name, placeholder, type. So the list of those attributes can be different for different nodes, and those attributes have values. So this is how an automation tool looks at the application. So when an automation tool works with the application, it needs to solve a few common tasks. So let's look what task it must solve. First of all, identification of elements. So let's return to the web spy. To find the elements in this tree, by the way, this tree is named document object model, so DOM. And to find elements in this tree, automation tool uses query languages. One of them is XPath. So you can see on the toolbar of the website an edit field where I can input XPath expression and I can test it. For example, to find this input field in the application, I need to write something like input. It has attribute name, and this attribute has value username. So hitting enter, and what I see in the test results pane is that this element was found. So I can right click this element, highlight, and I see it highlighted in the application. Another language that is used to find elements in the DOM tree is CSS. So let me enable CSS edit field. And if I will search for the input field using CSS, it will look something like input name, username. Okay, so found in this case as well. So when an automation tool records a test and captures the elements, then it generates such selectors either using XPath or CSS. So when we found the elements, what we need to do next? When element is found, we need to interact with this element. And there are different ways how we can send interaction events to the elements. First, we may send those events using browser level events or DOM events. Those events are processed by browser, Chrome, Firefox, or Internet Explorer or Safari. So those events are very good, but they do not work always. So sometimes, because of some modern frameworks used by the application, there are cases when such browser level events are not working. And in this case, an automation tool should be able to send operating system level keyboard and mouse events to interact with the element. So let's look at this using one of the puzzles. on the UI test automation playground. So there are a couple of them devoted to this specific problem, the click puzzle and the text input. I will use the second one, text input. So here is the puzzle. So let's record a web test that enters the value into the field. And if this value is entered successfully, when we click on the button, the name of the button should change. So let's see how it works. I will close the SPY. I will cancel. Here I have an empty test, no objects, no steps, and I'm going to record my test. So starting recording from the toolbar, clicking on the edit field and enter some value for the button. Here it is, new name, and click on the button. Okay, we see that the name of the button has changed. Finishing recording. And here is my test with the steps. So it clicks on the edit field, enters the value, and clicks on the button. So let's reload the application and run our test. And we see that the test enters the value, clicks on the button, everything is okay. It was a click, but the name of the button didn't change. So this is because that the application ignored browser level event and it just didn't work. When you see such a case during testing, then you can switch to using operating system level events to send a keyboard and mouse to the application. For example, to do this in rupees, I need just to go to my steps and change do set text to do send keys and enter what I want to put into this edit field. So let's return to the application, reload it, and then run our test. And in this case, rupees uses operating system level keyboard, and we see that the name of the button has changed. Okay, so there are two types of events that we can send to the application: browser level and operating system level events. Okay. One more thing that you usually do not notice when you are doing manual testing. So what is easy for a human tester? Wait for an application to complete some lengthy operation, or if application did not react to a button press, just hit the button again. So this is what you even don't notice sometimes when you're doing manual testing. This may be a problem for a test automation tool. And in some cases, you need to insert steps into your test automation, into your test script to wait for application to complete something and maybe for specific object to appear on screen. For example, in rupees, we have three ways how we can wait for something. There is a on the line 4, you can see global do sleep. This is kind of unconditional wait. So it just waits. In this example, it waits 10 seconds and then proceeds with the next step. On the line 7, we have a global do wait for, which is given the ID of the object from the object tree. And here it means that regularly the RPs will be checking for presence of this object, and if this object is on screen, then this test will proceed to the next steps. And if within a timeout period, which is 10 seconds here, nothing appears, then test proceeds to the next step. And on the line 11, we see global do wait for property. This is the way to wait for a specific property of an object to receive a specific value. So let's see how it works. To demonstrate that, I'm returning to the list of puzzles, and there are 3 of them related to different delays. There is a load delay, which is for delay on the server side when server does not send a response for some time. There is Ajax data puzzle that we will be looking in more detail right now, and there is also client-side delay puzzle, which is about some lengthy calculations on the client side when application is not responsive. So I'm going to Ajax data. So this is the puzzle that demonstrates that a request may be sent by the application to a server without page reloading, and the server may respond with a specific delay, and the application should be able to wait for something to appear on the screen. So I'm returning to my test. I will create a new sheet in my RVL. I will name it sync, and I will record a new scenario. So start recording, clicking on the button, and we see that a request was sent to a server. The server processes the request, and we have to wait until something will appear on screen. So it should be here shortly. So here we see a green label with some text. So I'm going to add a verification step that will check that we have this object and that its inner text has specific value. Okay, so finishing recording. I will reload the application. Here I have my steps. If I will run them as is, playing this sheet, then the test will fail. This is because Rupees by default waits for an object to appear for some limited time, which is configurable, by the way. And if the object is not found, then we have a failure in the report. If you want to change their default time, Rupees waits for an object, you can go to test settings, and you can change the number of lookup attempts, and you can change the interval between those attempts. So current settings say that Rupees will be waiting approximately 9 seconds for object to appear. In some specific cases, we want to add a synchronization waiting step. So I will add it here. So I will use global object that has do wait for action, and I will use the object that we recorded. So by default, it will wait for 10 seconds, and I can change the default. Let's set 30 seconds. Okay, let's reload the application. And I will, okay, not play, but play this sheet. Okay, it will hit the button, and immediately when the element will appear on the screen, the script should proceed. So we have a 30 seconds timeout. Okay, so we see that Rupees found the label, and the data in the label was exactly as we expected. Okay, so we are able to find elements using XPath and CSS. We are able to interact with them using DOM and OS level events, and we are able to wait for application to load and initialize data. So now we are ready to make a test. And there are two ways how we can create a test. So the first way is recording, and we did it several times. Okay, clicked minimize in the wrong window. Okay, so I'm going to create a new test at this point. Let's name it sample demo up 2. It will be a web test. I will use Firefox and I will use RVL. And I'm going to record the test with a sample application. Go into Home. Here is the sample application. And I will record my test. So during recording, objects are added to the object tree and selectors for those objects are generated automatically. So the tool Repeat does a lot of things for us. So let's enter username, password, login, logout, finish. Okay, so this is a recorded test. Here in the object tree, we have all the objects. If we go to object properties, we can see the selector, and also we have the steps. So this is one of the ways how we can create a test. The second way how we can do this is we can use scripting language and we can program everything by hand. So we just may ignore all the recording functionality and do everything by writing code. So for example, we can define a variable with username selector, and we know that it is input. We can determine this selector by using WebSpy or by somehow analyzing the application using built-in browser tools. So user name. So here is the selector. Then we may find this username by using navigator find, and we may pass username selector to this find, and then when we have the element we may do click. So everything was programmed by hand in this case. So this is also possible. When we have a test, so it's time to execute this test. And there are different ways how we can execute those tests. Okay, so let me proceed to execution types. So there are two ways how we can execute them. There is a headed execution. This is the way when we execute our test and the browser UI is shown on the screen. So let me fix something in my test first to make it working. I will explain this a bit later. Okay. Let me fix the selectors. Okay, so let me execute the test. And it will use the Firefox, and we see the UI. Okay, what is here? Okay, I need to return to RVL execution. I don't want to execute just the JavaScript part I created. So let's play. And the test is executed. using the browser. Okay, works. If I want to execute it using another browser in heated mode where we can see what is happening, I may select the browser here, play it again, and Rupis should open the browser. So heated mode is a good way to see how the test works and troubleshoot something. If something goes wrong, you immediately see what is happening. And the second way how you can execute your test is headless execution. Headless execution means that UI of the browser will not be displayed on the screen. So I have configured headless execution in Rupis. For example, let's choose Chrome headless execution. To do headless execution, Rupis uses Selenium integration. And if you want to find out how to configure headless execution in Rupis, you can go to Rupis knowledge base, do a search for headless, and you will see two articles. One of them explains how to configure headless for Chrome and another for Firefox. Okay, so I selected Chrome headless, hit and play. I will minimize my slides. So we see that test is executed and we don't see browser UI. Headless execution is good when you want to run your tests and you want to do something else on the machine, because headless execution does not interfere with your keyboard and mouse. So let's do execution on Firefox as well. So selecting it here, hitting play, and this time execution will be done on the headless Firefox. What may prevent us from doing headless execution? If we are unlucky and we have to use operating system level events to interact with the elements, enter text or click on buttons, then we cannot do headless execution for obvious reason. Because we really need UI, we need coordinates to click at the right place or send the keyboard. If our application is a good one and we can use just browser level events, then headless execution is what we may benefit from. Okay, and there is also remote execution. Remote means that we can execute our test even on machines that not only on a local machine, but on machines that are available in the corporate network or some farms on the network that provide access to different versions of browsers. So, for example, here I have configured the link to Safari, which is obviously running on some Mac machine on the network or on my network. So to see what is happening there, because we don't see the Mac machine in the session, I am going to enable screenshots. So I go to settings of Rupis and set capture execution screenshots. Okay. So let's look at the profile for Safari testing. So here is the URL and some settings for Safari. So hitting play, you don't see the execution. It is somewhere on another machine, but screenshots are on, and we'll see what was happening there in a minute. Okay, so we can see in the execution monitor the steps. Everything was okay, execution was successful. And here is the screen flow page generated by Rupis. And we see the screenshots from Mac machine. So here is how our test was executed. Okay, closing it. So we have a test, we can execute it in different modes, on local machine, on remote machine, in heated or heatless mode. And this is just the beginning of the journey. So when our test is ready, there are high chances that at some point in the future, this test will be broken and we will have to fix it. So now we'll be talking about maintenance of tests. And there are many reasons why a test may become broken. So most frequent reasons are developers update the application, something is changing in the layout, and some fields disappear, some fields are added, buttons renamed, and this influences test execution. Also, browser vendors update their browsers, and in rare cases, but sometimes it may also break test execution, and even updates to operating system may also break execution. This is a very rare case. So when tests are broken, we obviously need some tools that should make fixing the test an easy and quick task. So, and Rupees has many of such tools, and I'll show how they work right now. Okay, so I will create one more test where I won't be fixing the locators of elements. Okay, let's create one more. Sample app demo 3 will be web, Firefox. Okay, the test is created. Here is the application. I will start recording very quickly. I will get a test. Click in, user, password, login, logout, finish. Okay, so I have a test, and if I will execute it right now, it will work without any issues. Okay, we see username, password entered. Okay, test is working. Now I will go to the browser and will simply reload the application. Returning to Rupees, hitting play. And we see that the test does not work. And we'll try to figure out why. So we see that the test did not find username object. So one of the most frequent reasons when test gets broken is when it just cannot find some object in the application. Okay, so we'll try to fix the test. So the first tool we can use to examine the application is we can use Flash. So I'm expanding the object tree, finding the object where the test failed, right-clicking this object and choosing Flash. Flash just tests the selector of the object, and if it works, the object will be highlighted. And if not, we will see a message like this. So object is not found. So obviously our selector doesn't work. So let's see look at the selector. So I'm choosing the object in the object tree, go into its properties. Okay, and I see that this selector is searching for input field that has name username and that has ID like this. So let's go start recording again and learn this object once again to see what selector will be generated. returning to my test. I don't need this step. Here we have username 1. And if we look at the username we had before, it had this ID, which starts with 0E. And if we look at username 1, it has different ID. Okay, so this is because this ID is dynamic, and every time we reload the application, this ID is different. Okay, so we can fix this test very quickly by using relearn. So what relearn does is, so let me remove this username. I can choose relearn, and it will recapture the selector for the object. So I will click it here. The selector will be rebuilt by the tool. If I will use flash at this point, then the object will be highlighted successfully. But next time when the application will be reloaded, it won't be found again. So we have a selector which is not resilient, and it doesn't survive when the application is reloaded. There are two ways how we can cope with this problem. We can go here and just remove this part like I did in the previous part of this webinar. Or we can create a web application profile. So let me tell you about what is web application profile. I am going to the files view and select create web application profile. Web application profile is kind of configuration file that instructs Rupes what attributes to use to generate selectors for elements and what class names to use to generate selectors. So using web application profile, we may fine-tune recorder to generate selectors that are okay with application reloading or some small changes to the application. For example, if you will look at the default web application profile, here at the ID attribute, it says us that only IDs that are non-empty and that don't contain digits will be recorded. Otherwise, such IDs should be ignored. Okay, so let's re-record our test using this web application profile. I will just remove all the objects from the object tree. I will remove all the steps here. And I will start recording again. And this time, our piece will use different set of attributes to generate, okay, user, password, to generate selectors. Click and finish. And now, if we go to object properties, for example, username, and expand it, we see that Rupes does not use ID anymore, and it uses different set of attributes to find this object. So using web application profile, you may configure the recorder. There is one more tool that helps with healing the test with maintenance. It is called self-healing locators. So let me show you how those locators work. So to enable self-healing locators in a test, we need to go to documentation and navigate to self-healing web locators documentation page. This is a new feature that we recently added in Rupes 6.2. And to enable this feature for a test, we need to copy and paste this function to the main.js file. So returning to Rupes, let me just erase everything from here, including objects. So we have an empty test. I am going to main.js file and pasting the part that enables self-healing locators. So I will re-record my test again with self-healing locators enabled. Okay, let's go to Firefox, user, password, login, logout, click and finish. And this time, Rapis recorded not only XPath and CSS selectors for element, Rapis also recorded more information about elements. Rapis actually recorded almost all attributes and attributes of ancestors of elements. And now during playback, so let me reload the application and run the test. During playback, if XPath locator doesn't work, Rapis will try to find most suitable element on the page. Okay, so let's see. It seems I did not reload the page. Let's reload it. Oh, I have web application profile, so we have very good locators. So let me remove web application profile from our test. So we will not be using it anymore and re-record the test. So we need to capture those dynamic IDs, and we will see how Rapis will deal with this situation. So user, password, login, logout, finish. Adding my steps, reloading the application, play my test. Okay, Rapis is able to find the objects. Okay, and now we have a prompt. And this prompt says that some objects were not found using traditional locators, XPath selectors, and they were some candidates, suitable candidates were found, and we may just automatically relearn those objects. So if we want to do this and we click yes, we see the object change manager, and the manager says what objects were relearned during this playback of the test, and we can see what attributes of the object has changed. So we can see that XPath of the object is different this time. And we can just copy all objects and update our test, or we can not do this, and we can be just okay with the situation when Rapis automatically finds the objects. Let's look at the report. So what we see here? We see here that username was not found using traditional selector, but some suitable candidate was found. And we can see the difference. We see what attributes are different in the element that Rapis found. So we see that ID has changed. And we also see a snapshot of what was during recording and what was found during playback. So by looking at the report, we may see that we may find out if our test is still okay or we need to fix something. So these are self-healing locators, the way to automatically fix a test when something has changed. And of course, the last tool that can be used, can be always used, is a web spy. I showed it at the beginning of the demo. So this is the tool that helps you to examine the application. Here it is. You can analyze the DOM tree. You can look at the properties of the elements, and you can just see if their objects from a specific window can be found in the application. So here in the right side of the web spy, we have the object tree. If I will double click on the window and the element is found on the page, then it has this green check mark. If element is not found, we see this unhappy face, and we can actually fix the locator right in the spy. So we can build the locator, which is good and always finds the element. It will be username. Okay, so we found the element. Here it is. And here is the element in the object tree, username. And on the toolbar, I have a button, relearn username. So I can just, okay, I need to make a search again. Okay. It seems I have a typo in my expert expression. So it should be username. Okay, I found it. And I can use relearn username, and it just updates the selector of this element. So, and I can do this multiple times and fix all the objects on the page. Okay, so wrapping up. So we looked at the difference between manual testing and test automation of web UI. So web UI is very different from the perspective of a test automation tool. So test automation tool works with DOM trees. It uses XPath and CSS selectors. It deals with events at the browser and operating system level, and it also is able to wait for application to complete loading of data or initialization of some parts of the application. We also talked about execution of tests that can be done in a headed and a headless mode. Headed is when we see the UI of a browser, and headless is when the browser is not shown on the screen, but still renders pages. And we can run tests remote. I didn't mention parallel, but when we're using headless mode and we are not using operating system level events, this is a key to ability to run tests in parallel. And also, when we have tests, we can execute them when it's just the beginning of the journey, and we still need to maintain our tests because applications are changing and environment is changing. And to help with maintenance, we may use different tools like Flash, Relearn. We can configure Recorder using web application profile, and we can use self-healing locators that help us to fix our test automatically. Okay, so I'm almost finished. A few words about next webinar, and we will proceed to Q&A. The next webinar will be devoted to desktop UI testing, and it will be presented by Alexey Grinevich, our automation expert in desktop testing. So thank you for listening, and I am opening for Q&A. So Teresa, Alexey, do we have any questions?
Thank you, Dennis, so much for that in-depth presentation. Alexey, just before we get to the Q&A, let's take a quick look at the poll. So I'm just going to launch a couple of poll questions, and the attendees will have about a minute to answer each. So here's the first one. All right, fantastic. We'll close that one. And the majority of our attendees said that the content met expectations. So we'll have one more question here, and I'll launch that now. Great, thank you for that participation. We'll close that one now, and attendees found the content useful, so we appreciate your feedback. Now, Alexei, would you like to start us off with our Q&A session?
Yeah, we have a few questions, and the first one is, let me check. Which programming language do I need for web testing?
Okay, got it. A great question. So if we are talking about, okay, let me expand it. If we are talking about rupees, then if you are doing recording, then you can use just RVL, and we call it a language, rupees visual language. But it's not a language in a traditional sense. It means that you don't need to bother about syntax. You don't need to remember about braces or quotes or something like that. So the RAPIS guides you when you are doing this testing using RVL, which is called codeless testing. And if you are choosing the second way, so let me return to the first test that we created. If you are choosing to write something by hand, then to do this in rupees, you need to know JavaScript. So rupees is using JavaScript as a scripting language. Okay, do we have more questions?
Got it.
Oh,
Teresa?
Oh, I do see another question here. It says, is it possible to run web tests on mobile browsers?
Okay, so yes, this is possible, and rupees can do this using Selenium integration. So I don't have a profiles for mobile browsers, but if you have a web test that can run on a desktop browser, then you may configure, let's go to Selenium profiles in rupees. You may configure a connector to, so let me duplicate this profile. Let's call it Chrome Mobile. And here we can configure the link to a mobile device where Chrome is running. And we can run the same test without any changes on the mobile device, actually. So, and we have this covered in the knowledge base as well. So let me go here, mobile articles. So here we can see how to run a cross-browser test on a mobile device, and this is described in great details in this article.
Okay, great. I think we have time for this one more question, and it reads, how can I read a text displayed on the page?
Okay, good question. So far, when we did recording, we just clicked on the buttons or edit fields, entered some text, but we did not read anything from a page, but it's also possible. So let's return to our application and try to read something. So we can capture the object. So let's see if we have an object here. Username. Let's see if we can still find it. Okay, we cannot find it. Okay, let's capture the. Okay, what I did. Okay, I'm connecting to Safari right now, so it's time to switch to Firefox. Okay, and let's start recording. And let's capture the title of the page. So here it is. I will just add it to the object tree. Okay. Let me start recording again. So clicking on it. Control 2. Okay, sample up. We just capture it. Deleting. Clicking finish. And let's just remove all those steps and add the step here. Here is the sample app, and it is now in the object tree. And every object has a get inner text property that we can read. And the result of this property, we can just put it to the report. And we can use last result variable for this purpose. So let me play my test. And it should print the text in the sample app object. So here it is. Here is the text. So the answer is to use get inner text property of the object.
Okay, fantastic. Thank you, attendees, for those questions. And Dennis, thanks again for today's presentation. Just as a reminder, we will send out an email in a couple of days with a link to the recording of this webinar. And we'll hope that you'll join us for the next webinar in the series titled Automating Desktop UI Testing, which is scheduled for Wednesday, October 30th at 10 a.m., exactly 2 weeks from today. Thanks so much for watching.